It's a real pleasure to speak with you about this today, about climate change. This is the task that I was given to summarize historical climate trends, projections, sources of information, all in 15 minutes, tee hee hee. So it'll be a little bit of a wild ride, and I'm going to go right into another presentation. Kathy gave me double duty here to talk about climate models, so it'll be an even wilder ride. What you get from this presentation is a bit about observed changes, a bit about projected changes. I'll talk about the impacts and implications of those changes, and a little bit about some resources for information. Some of the take-home messages here is that it's a pretty darn good bet that we'll have hotter temperatures, as Kathy showed in her summary slides, particularly across the river basins of the Southwest. Lower precipitation, also as Kathy showed, is not necessarily a sure thing, but those increasing temperatures increase drought risk, fire risks. Because the atmosphere can hold more moisture when it's warmer, flood risks, and also public health risks. Drawing upon primarily three sources of information: National Climate Assessment, the technical report, where's this thing? There we go. Assessment of Climate Change in the Southwest, and a little bit from the IPCC Fifth Assessment Report. And I'm focusing on this 6-state region stretching from California across to Colorado and New Mexico. So I always start out with some of the non-climate factors, because climate interacts with all those non-climate factors, and one of them has been the rapid population growth in the region, and the population of the region is expected to increase by about 2/3 by 2050, according to the U.S. Census Bureau. Our region, believe it or not, by a certain metric, is the most highly urbanized region in the country, and that's because most people in the region live in pretty large cities. Agriculture, as you all know, this is pretty universal, uses most of the water, about 79% in the Southwest. And about half of the shipping container traffic into the entire United States comes in through the ports of Los Angeles and Long Beach, and I'll talk about implications of that. So some of the observed changes, I'm showing three panels here: a maximum temperature, annual maximum temperature, minimum temperature, and precipitation for the region. And as you can see, those vary quite a bit from year to year and decade to decade. But there's a really clear upward trend in the temperature in the region, whereas there's not a really clear upward trend in the precipitation. And one of the implications of that is that it affects snow hydrology. So we're seeing snow melt runoff occurring earlier across the southwestern U.S. and also at elevations roughly lower than around 7,500 feet. We're seeing a greater fraction of late winter and early spring precipitation falling as rain rather than snow. Some of that contributes to intensifying the ongoing drought, and in fact we have a measurable statistically significant decline in soil moisture across the Southwest region. As I mentioned earlier, because the atmosphere, a warmer atmosphere, can hold more moisture, we also end up with some intense storms. Kathy talked about how that's really important in the northern tier of the U.S. It also turns out that we have some pretty big intense floods here in the Southwest, like this one that occurred in the Phoenix metro area a couple of years ago. Having a longer snow-free season and warmer temperatures to dry out all those fuels that have accumulated over a century of fire suppression has led to a longer and more intense fire season across our region. And also, again, with that decrease in soil moisture, we end up with a lot of trees end up feeling kind of wobbly from the effects of hot drought, and then these little critters over here, pine bark beetles, can more easily exploit those trees. So we've had pretty massive conifer mortality across the region. an estimate from about 5 years ago was in Arizona and New Mexico was that between conifer mortality and fire, we've lost 20% of our conifer forests. And the number is probably greater at this point in time. And then I need to mention sea level rise occurring globally. The measurement off the coast of California is about an 8-inch increase over the course of the last century or so. But I want to draw your attention to the particularly strong increases during these El Nino episodes, which can lead to those sort of erosive events that Kathy mentioned earlier. In terms of looking into the crystal ball with climate models, what we have here is annual average temperature change for 3 30-year periods, 4 seasons. This is the average of 16 models, the big dots, and then you get the individual model projections with those plus signs. So across the region, temperatures are projected to increase by 3 degrees Fahrenheit, 5 degrees Fahrenheit by mid-century, and 8 by the end of the century, based on assumptions of continued high greenhouse gas emissions. And even though there can be quite a spread among the individual models, none of them are projecting temperatures to decrease. Associated with these increases in average annual temperatures are longer and more frequent heat waves, fewer cold nights, and more extremely hot days, all of which have ramifications for many things, including public health. Oop, didn't want to press that one. Again, the projection for the future, much like what we've observed, is that with increasing temperature, our snowpack will continue to diminish in each of the Southwest states. With precipitation, it's a little bit of a mixed bag. You can see that these estimates from different models, except maybe in the spring season, the yellow dots, cross the zero line. So we're a lot less confident in projections of future precipitation across the region. And Kathy showed this kind of diagram, and there's lots of questions about what might happen in this area where the models show less agreement. My colleague Jonathan Overpeck, focusing on the latest IPCC projections for the region and looking across the entire statistical distribution. On these IPCC maps, the hatched areas means that there's great disagreement among models. So his main point here is that for a lot of western river basins, in particular the Colorado, we don't really know what the future precipitation across the entire basin is going to be like. But with temperature, it's a really sure bet that temperatures are going to increase, and that will have an effect on things like sublimation and the amount of precipitation falling as snow or rain. And based on sensitivity analyses in the Colorado River Basin, a simple rule of thumb is that for a degree Celsius increase in temperature, we get flow declines of 6.5%, plus or minus 3.5%. So by mid-century, basically roughly around 3 degrees Celsius increase in temperature would be somewhere between a 10 and 20% decline in Colorado River flow, which matches up pretty well with the estimates that we put forth for the National Climate Assessment. Also, one of the things that's happening in the Colorado River Basin is that in the recent decades, demand has exceeded supply, and according to the Bureau of Reclamation, that gap between demand and supply is projected to increase in the future. Projections also include greater area burned across the Southwest, more occasions when we might cross that tree mortality threshold as drought becomes longer, more frequent, more severe. And then with rising sea level and the occasional El Nino event and big storm surges and things like that, there are potential impacts to infrastructure. Even with modest sea level rise, which is the light blue color, important airports like San Francisco and Oakland may become inundated without taking any adaptive measures, and that would have ramifications across the region. And if the ports of Los Angeles and Long Beach were affected, there's a lot of truck traffic moving all that shipping container goods across the entire country. And then with warmer shoulder seasons, disease vectors can breed for a longer period of time, exposing us to disease for a longer period of time. So the bottom line here is that it's a really good bet that we'll have higher temperatures. That leads to less water reliability, various other increasing risks. These are big challenges that require big solutions, and normally I'd go into my solution spiel here, but I think we're going to spend 2 days talking about solutions and other things. So I'll talk a little bit about resources. One of them is the Assessment for Climate Change in the Southwest U.S. website. You can get any of the chapters free as PDFs at this swicar.arizona.edu, plus our very easy to read 2-page fact sheets. Kathy mentioned the National Climate Assessment website. It's really climate from A to Z, everything from the basic science of climate change all the way through to mitigation and adaptation oriented solutions. The USDA regional climate hubs are doing a great job. The Southwest Hub recently published an ag and ranching vulnerability assessment, certainly worth a read. Carrie Inquist and others with the Southwest Climate Science Center, the Department of Interior Climate Science Center, are doing a lot of good work, outreach, and research related to ecosystem management. I couldn't help but mention one of my favorite resources, the Western Regional Climate Center website, where you can get these nifty anomaly maps on recent climate changes and trends. You can pick your favorite station and download data. You can link to the West-wide drought tracker, where you can get information at county level or climate division or hydrologic divisions, and get wonderful graphics and data as well. And I'd be remiss if I didn't mention the Applied Climate Science Lab at University of Idaho, which has a whole lot of really wonderful and graphically engaging products, summaries, graphics, and so on. Thanks for your attention. And now, on to climate projections.